good evening, everyone. Yes, thank you all for coming here on a Friday evening when it's raining and it's having a heavy traffic. Shows your commitment towards knowledge. So I welcome you all again. So IAF Chennai chapter, together with NCTS, has organized a technical seminar under the topic Urja Sanchay project on energy management at Meltshop. So this is the largest share of energy consumptions of foundries, which is accounts to 60 to 70%. So, Sir has been kind enough to audit some of the firms and provide his findings. With the welcome address for this session will be provided by Mr. Sendil Kumar Sir, our chairman for Chennai chapter.
Good evening, fellow Foundrymen. எல்லாருக்கும் மாலை வணக்கம். Good evening. அவர் முன்னாடி சத்தமா நான் சொல்லதனாரு. Good evening சொல்லுங்க. Okay. On behalf of IAF Chennai chapter, I extend my warm welcome all of you for this technical seminar on the subject of energy management at Meltshop, and jointly organized with NCTS. I think all you must be knowing NCTS is one of our CEO and Center of Excellence under the Urja Sanjay project. And as Siddharth told that energy, more consumption is in Meltshop, more than 60 to 70%. Whatever little saving we could do, that can create a lot of the or productivity, in terms of cost reduction, profitability, all those factors. And it is also helps us for the sustainability. Now we are talking about CBAM, everything, and it also helps us in that angle. That is precisely the goal of the Urja Sanjay project, a national initiative supported by company Eritech and Allied Refractories. And through this program, experts visit foundries and study the current practices and suggest practical, easy to implement solutions to save energy. And this initiative was first piloted last year in the Western region, where more than 60 foundries benefited across Western India. And I was told that the targeted saving exceeding 18 lakhs units of energy. And recognizing this impact, our current IAF president, Mr. Sushil Sharma, has now expanded this into a national program and to benefit foundries across India. And Chennai chapter has taken early initiative to participate in this program and successfully organize energy audits. The last 4 days alone, we had a privilege to covering 8 foundries. Fewer people are here, where experts have observed and guided and recommended specific improvements, and then response from members is also very encouraging. And today's seminar is the next step, bringing together our learnings and focusing on proven strategies, methods, and practical solutions in line with the chapter's theme, molding culture and casting growth. This seminar is not only about technical knowledge, but also about building a culture of continuous improvement, and that will shape sustainable growth for foundry industries. We are honored to have Mr. Anand Govindbaum, the eminent foundry, a consultant energy manager, who will share his expertise, address our foundry specific challenges. I also take this opportunity to sincerely thank our supporters of this program, Eritech and Allied Refractories. Experts from these companies will also add their valuable inputs during this seminar. I urge you to all absorb today's insights and take them back to your organization. Remember, let us ensure that every unit of energy saved in our melt shops adds to our industry's strength and sustainability. With these words, I once again welcome you all and look forward to an engaging, fruitful session. Thank you.
I now call upon Mr. Vignesh, our immediate past chairman, Chennai chapter IAF, to introduce our speaker for the day.
Thank you, Siddharth. Ladies and gentlemen, it gives me immense pleasure in introducing our first speaker for the day, Mr. Anand Govindbaum. He is a qualified BE Mechanical Engineering graduate, and he also holds a MBA in marketing. He is a household name in energy management. He was the past Western region, like Southern region like we have. He's Western region chairman of IAF during the year 2014 to 2016. And he has been an NC member, National Council member of IAF since the year 2010. And he is a certified BEE, that is Bureau of Energy Management, Energy Manager. And he is also an expert CBAM consultant and helps in carbon accounting. So he has hands-on experience, and he has visited many foundries throughout his career, and he has audited and helped them save a lot of money. That is the order of the day. So we are privileged to have Mr. Anand Baum amongst us. So let's put on our thinking hats and listen to what Mr. Anand has to say. Thank you, sir.
I must thank Chennai chapter and Mr. Senthil Kumar in person to allow me to conduct this Urja Sanchaya program at Chennai chapter. We had a brief discussion at Nagpur NC and wherein he finalized the dates and finalized the number of foundries as well over across the table. So that's how Chennai chapter works, and hats off to him and Chennai chapter's zeal, enthusiasm. So coming directly to the point, Urja Sanchaya project is undertaken by the IIF for benefit of its member companies with the purpose of identifying energy saving opportunities in the foundries and help them to create sustainable business model. This project was first launched at Western region when I was secretary to the region and Amish Panchal was chairman. In those days, about 10-12 years ago, we could cover about 72 foundries, and the results were encouraging. I continued that project when I was the chairman, but after my chairmanship, somehow it slipped the mind of other chairmans, and it took shape again last year when Saibal Sen took over as Western Region chairman, and that's the history what Mr. Senthil Kumar told, that there was substantial saving noticed, and it came to the eye of our president, Mr. Sushil Sharma. So he took up this project at national level, and that's how I am here in front of you. It's a walkthrough audit. We have got 4 hours. In that 4 hours, I or some other auditor will visit the participating foundry, and whatsoever may be, let it be APFC panel, let it be a core box, let it be a compressor, lighting, apart from induction furnace or for basic furnace melting, everything has to be noted, and wherever you find saving, it has to be communicated. That's the purpose of this. As he rightly said, 73%. This is pertinent to cast iron or Asian foundries having induction melting units. These figures are average of about more than 100 foundries. And so 73% energy is used in Meltshop to convert cast iron or to convert iron from ingot or scrap to usable liquid. Usually there is a misconception that whatever units are consumed for the liquefaction are recorded on the panel. No, sir. To run the panel, there is energy requirement. To keep the furnace cool, there is a pump house. To cool that water, there is a cooling tower. All these things together contribute to the melting energy. So as we have seen, Meltshop is a low-lying fruit because it's 73% contributor to the total energy consumption. So if we can save something, don't waste your time in shooting the photograph. I will send you the presentation and you can circulate it amongst your members. If we save something here, it becomes a substantial reward for the efforts. And instead of taking efforts on something which contributes to 2% or 5%, if we take efforts on something which contributes to 73%, naturally the reward is big, noticeable. These are the theoretical figures. How much heat, energy do you really require? Cast iron at 1480, 370 kilowatt hour per ton. And these are taught to us in thermodynamics. What is specific heat capacity of any metal? You can Google it. What's the unit of that? Anybody? Kilocalorie per kg degree Kelvin. So we are talking in terms of kg and kilocalories. What's the conversion? 1000 kg is 1 ton. and 860 kilocalories in 1 kilowatt hour. That also you can find easily on your mobile. So where does the remaining energy go? Because even if you find a most efficient foundry, figures are 200 units plus. Electrical loss 6 to 8%, radiation loss 3 to 5%, conduction loss 3 to 5%, coil loss about 20%. This goes to the cooling water. And combined efficiency becomes 65 to 75%. Add to it the energy consumed by the pump and cooling tower fan. Because here electrical loss means the loss in the panel itself. But to run it, we need these two auxiliaries. That is pump house and cooling tower. This is one of the important slides, that what is the importance of individual element in the melt shop or the furnace, and how its severity and whether it is easy to control or not. One by one we will go through it quickly. Lining condition. First of all, there are two aspects to it. Quality of lining and lining condition, I would say. Because lining takes up your 8 to 10 hours during sintering. So forget about production loss. The energy consumption in lining or sintering is equivalent to nearly 3 heats energy consumption or more. But it can be done as minimum to 3 heats. So you are wasting energy for 3 heats and probably production loss of maybe 8 or 10 heats. So that is a tangible figure. Production lost, you cannot cope up again. You have to work hard and hard to come to that figure. So you can quantify that and then allot it to the number of heats sustained by the lining. There are few foundries who do dirty work, not in Chennai, but somewhere in Rajkot, whose lining doesn't last even 100 heats. 90, 95 is that too. After 40 hits, they start patching. And at 90 or 95 hits, they break the lining. But there are some good foundries wherein the lining lasts for 1000 hits. So naturally, this X value which you spend, those 3 times the energy and 10 times the production loss, that value has to be divided amongst these 100 or 1000 heats. So longer the lining lasts, smaller is the contribution of lining. So you have to take care of lining also. That gentleman will brief you more about quality and good practices in lining. Secondly, optimum lining thickness gives you optimum energy utilization. If lining is thick, naturally your charge quantity is less, energy consumption remains same, so that gets divided on a smaller quantity. So your unit energy consumption goes high. If your lining is thin, then your conduction losses increase. Coil delivers the energy, but water takes it away. So again, it's a do or die situation. If it further thins, there is a danger of puncture. So optimum lining thickness is one which delivers you best ever economy. There are few foundries who are trying to make the former oversize so that they get maximum energy efficiency and a larger metal pool right from the first heat. But it requires precise control on your practices and consistency in practices. It's not anybody's job. If a lining is to last for 600 heats, they line it to optimum thickness right on the day 1 and break it at 300 heats. Because they go for expenditure in the lining divided by tons delivered by the lining. So to get that optimum figure, one has to work hard, do his own homework. So that's not my baby, that's your baby, because you are Foundrymen, you are working there day in, day out. So you can decide on your size of former, but as a auditor's recommendation, I recommend standard former, which is designed by the equipment manufacturer. Because they have designed the furnace with certain assumptions. They are committing some figure that my furnace will give you consume 560, 570, 540, whatever it is, based on their assumption. So you are purchasing the furnace based on your reverse calculation, based on their assumptions. So you stick to their recommendation. Coil level working. That's the only area which receives energy. Not below it, not above it. So if your coil is placed much above the bottom remains cold. If you are charging too much metal by raising your crucible height above the coil, that remains cold, and the energy received in the middle. So whatever is within the coil, it receives energy efficiently. And if you try to increase your holding capacity or dispensing capacity by raising the lining height, then you are not only delaying the heat, you are also consuming more energy. Occasionally, to adjust 1 or 2 odd jobs which really require 100-200 kg excess metal, it's all right. It's pardonable. But I again use the word pardonable, not acceptable. So it's a commercial decision. Instead of holding and doing something else, you can raise it for maybe 100 kg or so. But don't make it a practice. Charge material. Again, it's a commercial question. I would say techno-commercial. Clean charge material gives you best results. Because unclean charge material, dirt, dust, oxide, whatever it may be, grease, sand stuck to the runner riser, it's something else which you don't want in liquid metal. It's occupying the volume of furnace. It's taking energy from the electricity which you are supplying to take to that temperature, because specific heat capacity of sand is larger than specific heat capacity of iron. So if you say 5% sand is sticking to your RR, to heat that sand to 1480 or slag off temperature, whatever it may be, 1450, 1460, it consumes double the energy required to heat equivalent weight of iron. Point number 1. Point number 2, it is consuming volume of your furnace, active volume. So naturally, after deslagging, you have to add more metal. So your heat is delayed. You are consuming now 3 times energy, because that volume you have to fulfill by fresh metal. So 2 times consumed in heating the sand, 1 time consumed in remelting fresh metal. Third thing, slag. If not cleaned properly, you are inviting inclusions. If you want to clean properly, you are consuming more perlite. So why invite it? Because we get it. We feel that removing sand is costly affair. No, sir. This is the example. It's again validated. Here I name the foundry because those people really spend a lot. They had faith in me. It's Porwal Auto, Indore, Pithampur. They allowed me to use their foundry for any or all experiments and validation of those experiments. So there is a net saving of about 17 units a ton by shot blasting. charging method. In some foundries, I see that loose CRCA, long scrap sheets, are charged one by one, or maybe bundle of 10. How does the energy or eddy current or induction effect act on? It acts on the density or bulk density of the crucible inside. More the air, lesser is the effect. Less the air, higher is the effect. So if you are charging loose scrap instead of bale scrap, you are consuming more energy. You are not allowing that energy to penetrate in iron because there is no iron. There is air in between. So pack it densely. There are some good foundries who use pipe scrap or whatever available. Large castings, unbroken, rejected, unbroken. Break it so that the packing density increases. That particular, herein I use the term envelope volume. If you consider a pipe scrap piece or a scrap casting piece, its XYZ dimensions, that is its envelope volume. That much volume it's going to occupy unless it is completely molten. So density of cast iron is 7.6, 7.7. So multiply that envelope volume by that density, you will get the ideal density required. And you have got a weighing scale on the melting platform. Just weigh that casting. And then you will realize how much space you are wasting. Go as close to the density of cast iron as possible in your scrap contents. That enhances the efficiency of induction effect and that reduces energy consumption to a very great extent. Whenever you will charge loose scrap or your packing density is low, the furnace cannot draw current and a limit indicator is set on the panel. You are compelled to wait for that time, and furnace is taking out the kilowatts, but it is not able to convert it to heat. Your time is lost, your energy is lost. The photo on the left hand side is loose scrap being charged. All these photos are not from Chennai. These are old photos when I was conducting Urja Sanchay 10 years ago. Wherever needed, I will take the name of the foundry which allowed me to do that exercise. Cold start cycle. Mr. Venkat will be talking more on it. But if you cool the furnace fast, the cracks developed are shallow. So it is ready to heat up fast. So your cold start cycle timing reduces drastically. As against, if you allow to cool the furnace gradually, the cracks which are developed are quite deep. So those cracks take a longer time to seal. So naturally, your cold start cycle timing increases. Again, that's a time loss and energy loss. Luckily, I could have a comparator. What was the cold start cycle before creating awareness in my last Urja Sanchay? What is the cold start cycle? And this foundry number are those particular foundries which were selected 10 years ago, which were repeated last year. So the same foundry, same panel, people have changed. Maybe the melters do not remain at one place for more than 2 years. But the practices change. After educating them, you can see the average saving in the timing. Superheat. 10 degrees, 3 units. Keep it in your mind. Every 10 degrees, 3 units more. Do I really need to superheat? What's the need? First is loss in transfer. Can I preheat the ladle? Certainly yes. That will reduce the need of superheat. Can I reduce the travel time? Certainly yes. That will again reduce the need of superheat. Can I cover the ladle? Certainly yes. That will prevent radiation loss. Sometimes superheat is necessary, but then take care of it by preheating the ladle, by minimizing the travel distance, and by covering the ladle always. Excess holding time. 10 minutes holding, 20 units extra, 2 units per minute. In this visit, this was an example I gave to people. There was a debate, but later on they agreed to it. Yes, we can do something in it. And you go on reading all these reasons. Can it not be avoided? Certainly yes. If it is a team effort. But what happens? Today in every foundry, melting shop is enemy of molding shop. Core shop is enemy of both. And production planning person is the villain. So work cohesively. Morning meetings are necessary because planning changes every day, every hour. So weekly meeting is not enough. At least spare 5 minutes, 10 minutes. This is your role. This is what I want. At this time, in this quantity, in this condition. Because it's a chain. Unless you have core and mold, you are not going to get your mold ready. Unless you have sand, binders, mixer in condition, maintenance is playing an important role everywhere. Don't forget it. And most thankless job, I would say. They don't have holidays because holiday is the only day which they have got to repair anything. So try to respect maintenance people. It's due to them that the foundry is running. Excess treatment time. Again, keep the material handy. You are not foundryman for a year or so. There are foundries which are running for generations. So the recipes are already proven. Then why should a coin sample get rejected and you have to treat the metal again? There is some flaw in the system. There is no flaw in the written recipe. Try to find it out. Again, a minute lost is 2 units lost. In this visit itself, I could witness 2 hours of waiting in one of the foundries. I won't name it. I am not going to name any foundry because then it becomes a blame game. But such reasons can be avoided. 2 minutes, 5 minutes here and there is acceptable because everybody is human. To err is human. But hours together is not acceptable. Radiation loss. This is where I would like to thank again Porwal Auto and Devendra Jain ji himself in person, because he was on shop floor and he was ready to sacrifice his 500 kg metal for this trial. But when he realized that he is about to sacrifice it, that was a SG hit. So he said, give me 10 minutes. He ordered his team that keep CI boxes handy because it's going to fade and I am not going to throw the metal out. The result in front of you. Same furnace, same ladle. Uncovered ladle, 100 degrees drop in 4 boxes within 4 minutes. Covered ladle, 20-degree drop in 7 boxes poured in 8 minutes. What was the material for cover? Sera wool blanket. Result is in front of you. And Dada Jain will vouch for it any day, even if you wake him up from sleep. Anand was talking like this. Is it true? Yes. I have seen foundries wherein people bare feet, open hand shank are running with molten metal 30 to 40 feet, zigzag, zigzag, crossing molding boxes. Wake up. That's not the way to do. You have to grow up. Those are also humans. Forget human angle. But take care of your metal. It demands something. 30 to 40 feet travel in open hand shank of 50 kg leads to 100-degree drop before pouring. Again, you are compelled to superheat. No, sir, I have to pour it in that corner and I have only these resources. Or you don't have a square foot of Sera wool? You certainly have bundles of it. Just put it on top of it. Instead of 100 degrees, the drop will be 10 degrees. After a heat, can't you put the ladle upside down so that the radiation loss is minimized? Or use the same Sera wool blanket to cover it? Certainly yes. But no, I will keep my ladle like this, open mouth. So by the next heat, it's again at 40 degrees Celsius. So, what I say? My tips and tricks won't cost you, but it will save a lot. These are process improvements, disciplined actions, and discipline doesn't cost any money. Ladle size. Have appropriate size of ladle. There should not be any written metal. 2%, 5% here and there is acceptable because in MSMEs we don't take care of spillage and box lifting or something like that. So you have to save the casting. So naturally we keep some extra metal, but it should not be so much extra that it's cooling your furnace or mother metal. Slag. Where is the source? Again, the dirty metal. Why are you allowing it there? I give you an example of kitchen. You eat vegetable. Do you cook vegetable with the stem and skin along? You remove it first. You cut it to proper size. You keep it for cooking and you cover it. The housewife knows how to cook. Housewife knows how to use energy efficiently. But our shop floor people fail there. Whenever I do my technical consultation, I always compare metal treatment with the tadka given to the vegetable. Sir, can you tell that the taste of vegetable cooked by your wife has changed over years? No, na? Then why does our spectrosample get rejected? Because we don't practice. Recipe. What's there in the tadka? Oil. Then what that? Fennel seeds, mirchi, spices, onion, potato, end of it. What do we have in our tadka? liquid metal, ferrosilicon, ferromanganese, copper, tin, chrome. End of it. If that lady can take care of her percentages, why not we? She is not supported by the PC or the spectrometer. We are. But even then we fail. Learn from it. In a summary, if you want to take a snapshot, take it. This is the own extract of all findings. Before thanking, I would like to share my first-hand experience about this visit. I could find lakhs of units being saved that could be saved just by preventing compressed air leakage. What does it call for? Awareness. Remember, 1 mm hole in compressed air line leads to 2 CFM loss. And while lunchtime, if I am walking through the shop floor, I can hear hiss, hiss, hiss. What's it? What for? There are certain tests which you can take on your own compressor without any equipment on an off day. Just start it, let it cut off at full load. Once the pressure is attained, it will go to unload. Move through the shop floor. Keep an ear on everything. Note down at which place you are hearing the hissing sound. Seal those locations later on. But wait for the timing of compressor restart. That is the cut on. In ideal condition, if there is no application going on, it should take few hours to start again. 2 to 3 hours minimum. If it's starting in 15 minutes, half an hour, then you have serious problem in your airline. Second thing, do you really need high pressure, 6 kg, 7 kg, 8 kg pressure to clean your shirt and your mold? You don't. 2 to 2.5 bar is sufficient. Have pressure reducer. It's a one-time investment, 1,200 rupees on your downline. Wherever there is an air gun, it should be with reduced pressure, because the volume of air and its relation to the pressure is a square relation. Just imagine, what is 8? It is 2 raised to 3. So if you are using a low pressure application for mold cleaning, reduce it to 2 kg. It's equivalent to saving nearly 64 times the air being used by the high pressure gun. I found saving in shell core boxes. The box size is this much. The heater should be from here to here. If it is protruding out, I am heating the air along with the core. If there is no insulation between the mounting plate and the back plate, I am heating the machine along with the core box. Why? I found saving of nearly 68,000 units a year in just 3 small core shooters. You are lucky people, you are getting electricity at 6 rupees and 7 rupees a unit. At Kolhapur, electricity is 11 rupees a unit. At Vasai, it is 17 rupees a unit. So, don't use electricity lavishly. Use it for the specific purpose. Radiation loss on the furnace itself. The waiting time, which I told you, that the furnace is full but temperature is yet to come. Temperature has come, coin sample is taken, spectral report is yet to come. Spectral report is okay, now I am again raising the temperature to tapping temperature. This time is usually 20% of your total heat time. And that time, furnace, 100% of the times it is open to air. Cover it. Cover it with Cerawool when it is not in charging mode. When you are not putting something in or not taking something out, it should be covered. That reduces radiation loss, and that is equivalent to nearly, at some cases where L by D ratio is good, the surface area is small. There it is equivalent to 20 units per ton of saving, where furnace is slightly broader. There it goes to 60 units. So that's a very easy location and spot where you can save much more units. So remember, use energy where it is required. Saving energy at the melt shop, saving radiation loss at the melt shop not only saves your money, it also makes your environment workable. If it is open, it's heating the air. Your operator is feeling uneasy. He's going to run away in a year or so. But if you cover it, it will save minimum 20 units per ton. And again, here I would like to put a question mark. Kolhapur foundries are happy to sell cast iron at 80 to 84 rupees a kg, depending on wall thickness and core work. But in a similar capacity foundry, I found that they are struggling at 96 or 98 rupees a kg. Despite of having lower power rate, you are getting power minimum 30% cheaper than Maharashtra. So think over it. If you save here, you can be competitive. That's all for today. Thank you very much for patient listening. And I hope that you take up energy conservation, energy saving in a big way. And the last but not the least, the target given to these 8 foundries collectively, it's equivalent to annual saving of 53,25,600 units. I am ready to vouch it. I have already signed those documents and handed over to each and every foundry along with my signature. At the rate of 7 rupees a unit, it's equivalent to 3,72,200 rupees. That's the potential saving only in these 8 foundries. And I think there are more than 100 foundries in Chennai. So just think where this money is going. Not into your pocket, not into your customer's pocket, not into government's pocket. It's going west. Save it and earn it. If you view my WhatsApp profile, it says learn, earn and conserve. Learn how to do it efficiently. Earn money and knowledge and wisdom out of it. And conserve whatever you have gained. That's all. Thank you very much.
Thank you, sir. That was a really, really informative and eye-opening session. I think more details will be you will be getting it when you reach him in person. But first of all, thank you, sir, for all the information you have shared to this good August gathering. Now, every session is possible because of sponsors. So one such sponsor is Auritech. To introduce the speaker, I now call upon our Vice Chairman, Mr. R.S. Kumar, sir, to the stage. I request Auritech and the speakers following that to please maintain it at 15 minutes because we are now little running out of time and we would like to close it promptly.
Happy evening. I'm happy to introduce Mr. Vallabhesan Natarajan. He is a BE electrical and electronics engineer from Sanmuga Engineering College, Tanjavur. He began his career in 1998 with Pillar Induction India Private Limited as a service engineer, having 28 years of hands-on experience in induction furnace industry. Currently working as a sales manager in Auritech, southern region. Welcome to the stage, sir.
Thank you for you for this good evening and a wonderful opportunity. This is Auritech. We got started our company from 2006 onwards, and now we are more than 350 to 400 installation. We started our company with IGBT technology. Our USP is guaranteed 7.5% energy saving minimum with your existing melting practice. This we are achieving through our technology, design and concepts. I want to discuss about this and explain all those things. See, we are using IGBT technology, which is very fast switching comparatively SCR, and also we are making hybrid inverter technology. In the world, this is the IGBT. IGBT means insulated gate bipolar transistor. What is the difference between IGBT and SCR? SCR is silicon controlled rectifier. It is controlled by current. And IGBT is operated by voltage controlled. Voltage controlled means like switch. You don't need any snubber. You don't need any turn off time. So through that IGBT technology, as well as it has speed switching power more than 100 kilohertz. So with this technology, speed switching technology, as well as we are introduced in this DSP technology, digital signal processing technology. What is digital signal processor? The IGBT has 100 kilohertz switching power. We are switching the IGBT 100 kilohertz, more than 100 kilohertz, and with that we are controlling the power. This is our inverter power circuit. Here you see in world there is only two technology, one is current fed and one is voltage fed. In current fed we are controlling DC voltage, so it affects our power factor. So whenever you reduce the power, you are operating with less power, you are getting affected power factor as well as harmonics, more generating harmonics. And here we are using in voltage fed technology, the DC is switched on and they are controlling the power through the frequency. But there is the problem, whenever the series inverter has the very high current, switching high current, that's why if any problem occurs in the coil, continuously SCR, the power component failure. That is every time it occurs. So we introduced hybrid technology. Hybrid technology means here we are not controlling any DC voltage and we are controlling the frequency. And our tank circuit also parallel tank circuit. With that we are achieving maximum 97% efficiency, more than other panels. So you see benefits of Voritech hybrid inverter design. I already told you. This is what are the types of inverters we have: voltage FET, current FET and voltage FET. How it is working? Hybrid technology. Here what is the difference between IGBT and the thyristor? Thyristor required RC stepper. It is wasting the power. And power conversion efficiency is more in IGBT because of we don't need the turn of time circuit. And it operates very high frequency. Here short circuit protection is very less because of we are using DSP technology. That's why this IGBT is used nowadays in Vande Bharat trains, as well as every DC drives, every welding machine, everywhere we are using the IGBT. So through the technology we are saving minimum 2 to 2.5% energy. And now our layout. Our layout is you are seeing many more furnaces, many more power supply. There is lots of bus bars, copper bus bars is going through here and there. So already sir told, we have I square R loss, very heavy I square R loss because of frequency as well as the bus bar going there. So it is heated up. So we are having very loss. So reduce that loss. We shifted our reactive power to near the coil. In our panel, if you are seeing up to 350 kilowatt, we are not using water cooled cable. Up to 350 kilowatt, only air cooled cable we are using. And very big furnaces, for more than 5 ton furnaces, we are using 1.5 meter only water cooled cable. In water cooled cable, you will get the more than 6% power. Here you see, here our installation is here. Very neat and clear, no bus bars, nothing is here. This is our furnace. Our furnace is combined, all the furnaces, steel frame furnace combined with tank capacitor. Because of, thanks to IGBT, we are making the parallel tank circuit near the coil. That's why we are saving energy through saving reactive power. Because all the panels are containing their capacitor, tank capacitor inside the panel, and from that they are using the copper bus bars, trench bus bars, more length. So there is I square losses are more. So that's why we are putting our capacitor parallel the furnace. So there is no need to worry the component failure and water cooled failure. So it is also gives very less maintenance. Build quality, it saves 0.5 to 1.5% energy. Here we are from 500 kg we are making steel frame furnace only, not box furnace. Because due to box furnace we cannot save the energy. Due to using the core, we are saving the 2%, 1.5 to 2% energy we can save the power. But in this normal core, only we can save maximum 0.75 to 1% energy. Same CRGO core with high quality we can use, because here our competitors are using only 125 kg, 125 rupees per kg core they are using, but we are using 400 rupees. That is called amorphous core. Amorphous core means it acts very high frequency and it acts very efficiency. We are using amorphous core, that core is very thin, like that we are using. So in that our furnace, if you see, there is no cooling at all in the core side, inside the core there is no cooling. But if you see any other furnace, any other kilowatt furnace, steel frame furnace, definitely they are providing cooling side copper plate. So through this here see we are reduced our bus bars. Here we are assembled the panel bus bars. Inside the panel, these are all the bus bars. This is our capacitor, tank capacitor assembly. So already sir told about this, the radiation loss and other losses. Through this, we are guaranteed saving minimum 7.5% energy. But if you are doing more practice with this existing SARS advice practice, we can save more than 10% energy. So 7.5% energy means for 500 kilowatt minimum 36 kilowatt hour per ton we can save per melt. Per ton per melt we can save melt to melt. Now we are installing our panel 6000 kilowatt 6000 kg dual rack furnace in Sandfit, Coimbatore. So that is the very cast iron foundry. And in Kiswak, Kejriwal Industries, Kolkata, they are achieving 490 unit kilowatt hour per ton through our 5 ton 3000 kilowatt dual rack unit. So here we may be new now, but we are doing very lot of work. We have more than 350 to 400 installation in every steel plant. Now we are more than 10 orders around Coimbatore in steel plants. But we are need opportunity in foundry. And Kirloskar Ferrous also we are supplying dual track IGBT. This is thank you for this kind cooperation with me. Thank you.
Sir, thank you for the crisp information shared. Next, I call upon Mr. Vignesh, our immediate past chairman. Our next speaker for the day is Mr. Venkatesh Selvaraj from Allied Refractories. A brief introduction about him. He is a mechanical engineer with 15 plus years of rich experience. He has begun his career as a graduate engineer trainee at Vedanta Aluminium Limited, Odisha, where he quickly advanced to assistant manager handling maintenance activities in the primary aluminum smelter. After 4 years, he transitioned into sales, joining Allied Refractory Products India Private Limited in 2014 as a sales engineer. He has been with the company over a decade, taking on various roles and responsibilities. He currently serves as a regional manager, sales, leading the sales and service teams for the southern region. He has been recognized for his outstanding contributions, receiving a sales performance award for Foundry and HTF segments from the head office, Allied Mineral Products LLC, Columbus, Ohio. He travels extensively to attend customer needs throughout the region, providing the specialized factory solutions outside of work. He enjoys reading self-help and management books. I welcome Venkatesh to the stage, please.
Thank you, Siddharth, for the introduction. Good evening, everyone. And I thank IIF Chennai chapter for giving me an opportunity to have space in front of you. And last 4 days, it was a wonderful journey with Mr. Anand Bam sir. So it was like a lot of things were new to me. So we always think things in a straight way. So if we need to have always a third eye, so to tell us that this is not the way you should see the things. So thank you, sir, for your time. Most of the things has been already covered by sir very beautifully. So there is nothing much to elaborate further. So I have just made like few slides to further emphasize whatever sir has discussed with respect to the lining point of view. Myself, Venkatesh, so already brief introduction is given. So our company introduction, Allied Mineral Products, has been founded in 1961, and it's an employee stock ownership program company. It's a ESOP company, financially solid, and we have 1,000 plus employees globally. We have 15 manufacturing locations. Recently, we started a manufacturing location in Turkey, and we have 8 shape manufacturing facilities around the globe, and 3 R&D centers, and actively sales over 130 countries plus, and we have 160 plus sales representatives along the globe. So this is just a pictorial representation of our company's presence over the globe. As you can see, almost we are present in each and every country. So these locations are our manufacturing and licensing locations. So what is the relevance of lining life and energy saving? As Anand sir has explained, optimum lining thickness always give you a better energy saving. So increased lining life reduces the overall power consumption of the throughput. As I said, sintering heat consumes three times your regular power consumption, your regular heats. So if the lining life is been prolonged, this additional sintering power is being distributed to the extended lining life. So lining life depends on various factors. So we cannot have a constant lining life even in the same foundry. Lining to lining life differs, and company to company, foundry to foundry lining life differs. It all purely depend on our practice, how we handle lining efficiently. So if we properly follow all standard operating procedures, we can definitely maximize the lining life, and we can make a maximum out of the lining. So a rapid cooling and a proper cold start, these are the two things I will be discussing further detail. So I've just kept like 2-3 segments instead of going completely deep. So if we consider these 3 parameters, we can have maximum life. One main thing is that grout lining. Grout lining generally not given importance, it has to be given. So what is the purpose of grout? So purpose of grout is like two main purpose it has. One is like to give smooth expansion and contraction for your main working lining. Second one, it insulates in between the coil. So if you see, ideal grout has to have a 3-degree taper from the top to bottom, and it has to have a very smooth surface. If your grout is not smooth enough, if it is having any ups and downs, when lining try to expand, it gives a stress to the lining, and further it gives a cracks to the lining. It will reduce your lining life. So I've given one example of a bad grout. Here you can see these are all the lining hang-ups when a lining try to expand and contract. From the back, it will try to create a stress. Further, it will have a horizontal crack. Horizontal crack may not be sealed even though you do a proper cold start. Only vertical cracks or though cracks can be sealed if we do a proper cold start. And second thing is that spout lining. Generally, spout is being lined with a different material rather than the working lining. Either sodium silicate or some other binder will be added, and it will be placed after doing the lining. We recommend to do the spout ahead of the lining. So it gives you two advantage. One is that your joint is being shifted from this particular location to this location. We call it as a vertical plane design. So now in the vertical plane design, these two have become completely different entities. So when lining try to expand and contract, it will not disturb your spout. And in the other case, in a general conventional practice, people put spout lining on top of the main working lining. Spout refractory and the main working refractory has a different expansion rate. When this main working lining try to expand, it will try to push the spout lining. When you try to contracts, there will be a separation. So it will not, because of the expansion ratio, it doesn't seal properly. So what happens, this particular joint always in a metal contact. So there are high chances that metal getting penetrated through the spout and main working lining, and gives you a GLD trip. So if we do the spout early, so the joint shifted from here to here. So there is less chance of metal getting penetrated through the spout to the coil. So in these two pictures, you can see the difference of vertical plane design and other design. So here the joint is very clearly visible. Even we can patch it even though metal is present inside. In the other case, you have to completely demolish. In maintenance point of view also, this particular design is always safe. We recommend a plastic refractory with a chrome oxide addition. This chrome oxide will give you added advantage of non-wetting properties. So the metal and the slag doesn't stick to your spout, and even if the metal is getting solidified, you can easily remove without damaging the lining of the spout. If you use a plastic refractory, it always has some moisture of 2 to 3%. This moisture has to be eliminated before we introduce the main working lining. If you are not heating the spout before your lining, the moisture will affect your main working lining, and also when you try to shrink, when you do the sintering, there will be a separation of because of the shrinkage. So there are chances of metal penetration, leading your lining failure earlier. And another aspect I would like to cover upon top cap refractory. So the same way how we dealt the spout refractory, people used to do. I've given like couple of examples. So this is how generally maximum of the foundry will be having the top cap. So they will be using with the main working lining with some binders. They will try to form a heap on top of your top block, and because of the thermal shock from the top to bottom, there will be a lot of cracks in the this extended top cap. So we recommend to use a dry top cap, which is having a additional binder to take care of your impact of your charge and the thermal shock. By added with the fused silica. Fused silica is better thermally stable product compared to your normal silica. So with these two ingredients, we can achieve a better strength and better thermally stable top cap, even though it is a dry. So how we have to install it on top of your power coil level? You have to make one transition layer with the special top cap and your main working lining around 2 to 3 inches, and on top of that you can install this top cap material. So this will allow a homogeneous mixing from working lining till top block level. We always recommend to have your top cap only till your block level, not to form any this kind of additional heap kind of structure on top of your top block. So here also there are chances the metal get penetrates through the crack, and it gives you a jelly trip. So there are some special dry top caps available even for the iron applications as well as steel applications, which can be used. And now we'll talk about sintering, how sintering will affect your main lining life. Refractory understands only the temperature, so it doesn't understand the kilowatt reading. But as an age-old practice, people used to follow the on-off cycle and slow heating cycle. But how much kilowatt is giving you what temperature, nobody knows. So we have to do an initial sintering based on the thermocouple values. Depending upon the furnace size, we recommend either 1, 2 or 3, maximum 3 thermocouples. The thermocouple has to be placed in a bottom, one half of the furnace and 3/4 of the furnace from the bottom. So we recommended 110 degrees Celsius per hour rise in the silica and 222 degrees Celsius per hour for the neutral ramming mass. And silica has a phase transformation. So around, if you can see like 870 degrees Celsius, it transfers its phase from quartz to tridymite. So we recommend to give a particular amount of soaking time during around 900 degrees Celsius, so that it has a time to transfer its phase from quartz to tridymite. And final holding, it will transfer its phase from tridymite to cristobalite. Excuse me. So this point already Sir has given with proper numbering how much volume of a pipe and other things will occupy. Not only for the sintering, we always recommend to have a densely packed charge to draw more power instead of power wastage. So during the sintering heat, the metal level has to be till top of your top block, and for subsequent heats, you can have your metal level till power coil level. So rapid cooling, generally people used to have a different school of thought. They think that if cooling is slow, thermal shock is less, so they will be having a better lining life. But we recommend a rapid cooling. When you do rapid cooling, there will be many cracks, but the cracks are not deep enough. It's very shallow. When you do a proper rapid cold start again, these shallow cracks will seal automatically with a lesser heat. So for this rapid cooling, furnace must have smooth grouting and spout lining interface must be clear. Position airline or portable fan above the furnace. Avoid localized cooling. A rapid cooling develops numerous small cracks, shallow and shallow hot surface crack, which close up quickly upon subsequent heating. So this is like a two method we can do. You can have a duct which is on top of your one side. So this air can be circulated from the left towards the right. Whenever you do this rapid cooling, the joint between the spout and the main working lining has to be cleared off. If there is any solidified metal or slag is stuck in the joint, it will not allow your lining to cool down. It will not aligning contract further. So it will also create a problem. So you have to chip off the slag or metal, whatever is present in the joint, and you have to do the rapid cooling. So the other way, you can use a fan to rapid cool. So all refractories expand on heat up and contract and cool down. So these thermal cracks has to be sealed before being exposed to the liquid metal, and failure to seal cracks will result in finning or lining failure. So this is how the crack propagation starts. It will propagate from the hot phase, and it slowly enters to the semi-sintered refractory, and it goes to the loose back-up. Metal expands 3 times than the refractory. So whenever there is a fin already present in your lining system, it will be slowly getting towards your coil very fast. So this will lessen your overall lining life. So for cold start also, you can able to place thermocouple and understand the temperature. So you can rapidly heat the furnace up to the 900 degrees Celsius. So, but before introducing, start melting it, you should allow some 45 minutes to 1 hour, so that the cold lining gets the heat in, try to expand. So all the cracks, whatever shrinkage crack has been happened, it will allow the crack to get sealed before the metal fin. So scope of energy conservation in melting equipment, coreless induction has a major scope, which is already briefed by Mr. Anand sir. And transfer equipment, treatment and pouring ladles also effective way of saving the energy. So I just have like 3-4 real life case studies where you can have an idea how to save energy. So in one of the ladle, the lining thickness is same. It's like 75 mm lining thickness, fire clay based castable. It's directly lined onto the steel shell. For hot phase temperature is 1450 and the cold phase is 420 degrees Celsius. So the total loss of heat is like 16,000 watt per meter square. By just introducing a 6 mm ceramic fiber paper, you can save up to like 40% loss through the shell. And the cold phase temperature has been 17 degree has been saved. So during our visit, one of our foundry also emphasized this introducing of CF paper. Earlier they used a castable without the CF paper. They were losing the heat very fast. They have to reheat the ladle in subsequent heats. But after introducing the CF paper, the heat containment was more. So they don't need to heat the ladle for further heats. The heat was retained well. And this is another case where we run a steady state heat analysis for inconel metal. Both the sides, everything remains same. There is lining thickness, liquid metal temperature, and air emissivity. All things remain same, except, as sir was saying, cover your furnace, cover your ladle. There was just an introduction of 50 mm blanket. So you can see the drastical number. So temperature drop after 10 minutes is 57.9 degree without cover. So it is just 6 degree with a cover for 15-ton ladle. So you can see how much energy can be saved in your induction furnace. So generally the radiation losses are more than 70 to 80% than the conduction losses. So we should target the radiation loss than the conduction losses through the refractory. And also we recommend to have a proper refractory design for reducing the 30% loss through the shell also. So there was one customer who had like 10-ton and 5-ton furnaces, but he wanted to pour like 25-ton liquid metal. So he gave us a challenge to hold a liquid metal in one 5-ton ladle for 1 hour. So if you see, this is the design we have given: 6 mm ceramic fiber paper and 32 mm insulation fabric, then 75 mm of the castable lining with the 100 millimeter cover. So this is the heat loss we are given theoretically. So heat loss after 60 minutes we are given 52.2 degree. Since the ladle is very big, so they could not fabricate the cover according to the design. So instead they did like after taking the liquid metal, they poured the perlite ore or rice husk. So they could able to achieve 80 degree instead of 50 degree. So 30 degree more loss was there, but still they could able to pour the liquid metal after 1 hour waiting in the ladle. They treated this ladle as a holding furnace kind of stuff. So that's all I have. So if any specific questions here you can ask, otherwise we can discuss during the dinner. Thank you. Sir, actually we go with the temperature based sintering instead of a kilowatt based sintering. So we recommend like 110 degrees Celsius per hour for silica ramming mass. So at 900 degrees Celsius, depending upon your furnace size, we have to hold either 45 minutes or 1 hour. So then you can further go the same 110 degrees Celsius per hour, and you can melt it around 16 degree by giving 1 hour holding at final hold temperature. But based on our experience with the larger grain size silica, you can go up to 150 degrees Celsius per hour also. You can little bit increase the ramp with the grain size distribution.
During phase transpiration,
yes sir,
that time the temperature will be holded or
it will be holded, sir. During a phase transformer, it has to be holded.
that means it will be extended the sintering time, no?
Yeah, but holding has to be given, but we can increase the ramp up cycle little bit. Instead of 110 degree, we can go up to 150 degrees Celsius per hour.
That time it will reduce the...
Yeah, ramp time will be reduced, but holding has to be given at 2 places.
Yeah.
One is around 900 degree and one is at the final holding to form the final phase transformation in silica ramming.
in between that 573...
That is not needed, sir, actually. That can be skipped. 573 alpha quartz will be converted into beta quartz. But it will be compensated when we give a holding at 900 degree. It will be taken care. But it will again additionally increase the sintering time. 573 degrees Celsius, if you want to introduce another holding, it will again increase the time. That can be given cushion if you hold at 900 degrees Celsius.
That's why I asked you how it is reduced the sintering cycle time from...
Only by ramping at a higher rate. But holding has to be given, sir. Then only it will be having proper phase transformation. Otherwise, instead of forming the hot phase, if you introduce the liquid metal, it will have a saturation. It will suck all the oxide and it will penetrate through the porosity in the main working lining. So that, in case of steel, there is no need of holding. You can directly ramp up to 220 degrees Celsius per hour and you can hold it at final temperature, final tapping temperature plus 20 degree. There is no any intermediate holding because the binder is different. There is no binder. It forms a spinel bond with alumina and magnesia. When you heat at a certain rate, it will form a ceramic bond. But silica doesn't get binder on its own. We have to add an external element, either boron oxide or boric acid. That is the additional agent. Its purpose is to sinter the refractory and make it hard. So depending upon our tapping temperature, the binder has been decided. If your tapping temperature is high, the binder should be low. So vice versa, if you are melting copper in silica ramming mass, the binder should be like 1.5. It should be higher.
So one more, that cold start sintering
Yes, sir.
the same.
Huh.
So sir, in the slide, before educating that,
Yes, sir.
2014 is a 90 minutes. After that, it will be come to 70 minutes.
Correct, sir.
It is only for the education, or it will be changing or something, anything.
No, sir. Sir has given a practical figure.
Case study.
That is the
Case study.
of 10 foundries. I have given 10
Yeah,
numbers.
that's why I asked
So in
in
the
the
same
first.
foundry after 10 years, when I went, they have followed the practice of fast cooling and
Yes.
fast cold start.
That is only the
That is
change.
the saving.
That is the only change.
Yes.
Yeah. Thank you, sir.
Thank you, Venkatesh. I know you guys might be having much more questions. You guys can discuss it over dinner. First, I would like to thank Venkatesh sir, Oritech speaker, and Anand sir for their lovely talk on saving energy and how much cost savings it can give to the companies. Now I would call upon Mr. Sendil Kumar sir, our chairman of Chennai chapter, to felicitate Venkatesh sir with our traditional Angavastram. Now I call upon our immediate past chairman, Mr. Vignesh, to felicitate our Auditech speaker, Mr. Vallabesan Natarajan, with our traditional Angavastram. Thank you. Finally, I call upon our governor of Chennai chapter, IF chapter, Mr. Varadarajan sir, onto the stage to felicitate our main speaker for the day, Mr. Anand Bam, with our traditional Angavastram and a memento. Thank you, gentlemen. I think you guys would have a lot of thoughts to take back home and implement in your companies.